Yo, what's up, what's up, what's up, what's up? Welcome back. Today we're working on my to-do file system. So the idea is that I have tasks that I want to do on stream. They have to be broken down into like 2-hour chunks that have like a bit of like a story with them, right? Like we're going to implement this feature and it's going to take 2 hours, and this is going to like the chain of events is going to get there, right? That like just kind of makes it so that like the flow of stream kind of works well. There's kind of like progress happening. Keeps it interesting, right? Versus just kind of like blundering around implementing whatever the next thing that we think of is. And also it helps like with if I have a pool of tasks to choose from, that makes it easier to plan out like my week and stuff, because then I go like, oh, I just have like 7 tasks that all chain back to back, and that makes it really easy. Like that's my week. And so I'm starting to have trouble tracking all of the like different paths that we can go down. So I need some sort of like structure to next tasks, right? And what I want is chains of events that can be easily visualized. And I want to easily see like what chains of events I should start unlocking, right? You can imagine that like I'm working on my like image to text AI project, and that like maybe one of the things that I want to work on here is like moving it over to Rust, so that I can experiment with like running a neural network in like normal code without using like these like Python dependencies. And then maybe from there I want to say like, oh, what if we ran it in the browser with WASM? And from there, what if we made like a little like website that you could use to like upload an image and get like my ASCII version of it. And then maybe like on this path, after I port to Rust, we can also look at like SIMD, but that's kind of like independent of this stuff. And maybe we want to look at like SIMD and WASM. So maybe there's like some sort of like SIMD plus WASM. Maybe that's like different. And so that kind of depends on these two things. Then there's like a whole other branch over here about like color. So I might want to say like finding foreground and background colors, maybe in black and white. Then maybe with color. Maybe I know that I want to experiment with like different loss functions here, because I might want to be able to like automatically discover color. So maybe there's like another like path of investigation down here. Basically, there's like trees of events, and I want to be able to like quickly look at the whole tree. And I like looked at like, I've used like Jira and Trello and stuff like that, and like existing like ticketing systems that have the benefits of like letting me like have tasks with well-defined like outputs and stuff. They don't really have like this type of view as far as I can tell, like a quick at a glance look. And so I'm kind of thinking is, well, what's like the simplest way for me to get what I want? First of all, what I want is not very complex, right? I don't need like anything that like these ticket trackers provide other than just like files that have content, right? It's just note files of like, here's what I want to work on that day, right? The tickets are essentially what you're showing on the top right. I just want this, but with like relationships between them. I'm like, okay, so what if I wanted to just like show relationships between files? Well, I could like symlink them together on my disk. That's like the simplest version of this. The problem with that is if I want to go, if I have like a relationship that says like, when I go for Rust, I'm going to like, well, I want to link that to this, and this, and this. And if I want to look at any of these guys, they all have to be linked backwards as well. So there's like these like complex two-way relationships or multi-way relationships that I could imagine being difficult to maintain if I just wrote symlinks everywhere. So what's like the next simplest option there is maybe I just put all of those relationships in a database and automatically construct those on the fly with like a little file system. And so that's kind of what I'm thinking is I think that using the fake file system as an interface to my database is something that should be like pretty straightforward and gives me almost exactly what I want, right? Like I built up like an example tree over here, and I have like projects over here, and over here I can say like, oh, these are all the children of this project, and this is the ones that I can start working on right now. And if I like look at hold on, have to install the utility, but like I can just use then like normal Linux utilities to get like the visualizations of stuff that I want. So if I like run this like tree command, I can see, oh, here's like the tree essentially of like dependencies. And so where we got to last stream was we built up this like fake file system that doesn't really do much, but it does. Let's see if we can show. We have the ability to mount our file system. So if I type mount, I have this like to do file system on test mount, which is of like a user space file system. And in here we have like these folders that right now don't really do anything, but they are named based off of what we see in like a database that we wrote out. So these guys are fetched from a database and shown in the file system. And that's kind of like the bare bones of what we're trying to do. And now what we want to do is we want to map those to like real files on our disk and be able to interact with them. And then if we get to that point, then maybe we start like linking them together in some way. So the goal today is just trying to like get some sort of like file system pass through going on, which I don't think should be too hard. So we're gonna like put some files in the database, so that should show up under here. Start trying to like modify the contents of them and see what happens. Yeah, so that's the plan for today. Yo, what's up? Good to see you too. Let's just start with like putting some content in there. So the way this works is we have like this database of files. I should probably pull up SQLite browser as well, so it's easy to look at. So we have like basically our files, our like database is laid out right now as each item that we want to work with has like an ID, just like a numerical ID, and associated with that ID is a database, or sorry, a name and stuff in a database. So if you look at this database, all he has in him right now is he has one table, files, and he just says, hey, ID1, that has a name, ID2, this is a name, ID3 has a name. So you can imagine this is like a ticket name, or if this was going to be used as like some sort of like document storage, this is the document name, and this is tied to ID. Eventually, we're going to use these IDs to like build up relationships and like tags and filters and stuff, but for now, this is all they are. Each ID has a folder next to the database, and this is like content for that ID essentially. Then when we mount the folder, which we can do like this, then the names in our database, I lost the browser, shit. But the names in our database get mapped as folders here, and these should, when we go into them, ideally they would just map directly back to the folders of like the files in our database, but they're not doing that right now. So that's what we want to implement. And so I guess the first thing we want to do is we want to put stuff in there so we can prove if it's working correctly. So here we can just like touch test1 stuff. And here we can like make a directory hello, and maybe over here we'll make dir test2 or something. So these guys have like content inside that we should see in our mapped files or a mapped file system. And all we then have to do is find a way to like hook that stuff up. So we go into our Fuse client stuff. I would like to jump to definition, please. There we go. And all we do here is we construct this like operations thing that says like, hey Fuse, when somebody calls make dir, call our function and we'll decide what to do with that. Or if somebody calls rmdir, we'll do that, or rename, we'll do that. And so we just have to start like stubbing out functions that essentially pass through. They like they look up what file path that people are trying to modify and pass through those commands with normal Linux syscalls to the corresponding like real paths, I guess. So I guess let's just try to like get the correct listing of files, which should be doable with this like read directory call that we have right now, which basically says like, hey, I'm in a directory, I type ls, what's in there? And so here right now, we're just kind of hard coding. No matter what they ask for, we give them all of our items from the database. We list each one's a folder, but we need to like decide that that's only what we do. We have to like switch our behavior based off path, I guess. So we need some sort of way to map the input path to the correct database path. So let's just kind of like start looking at what that would look like, what that involves. So what we say like function map path, which takes in a path as a string, I guess, and returns, I guess we'll take this in as a path and return a path buff. Probably. That makes sense. Which means we have to pull in path and path buff. And what does he look like? So he like looks at the DB, the database, and he says, well, let's see. So for now, we'll assume that our like layout in our in our like fake file system is we'll have a like the root folder will just have our item. So he'll have no, that's not what we want to do. Let's add a new area in the file system that we call like by ID or something. And then he will just basically straight up copy the layout of the original guy. Does that make sense? Because I'm thinking like if right now the way we have it right now, which I need to show somehow. So let's write this is unimplemented, so it compiles and runs again, unimplemented. The way we have it right now, we have the name of each task at like the root level. But there's nothing preventing us right now from having like duplicate names, and I don't know if I want anything to prevent us from having duplicate names, which means that like names are not a good indicator of like a unique folder. Which means that probably what makes sense here is for us to have IDs here in some way. And we can then put like links to these things by IDs, which makes this really easy. Because then we can just say that like we have everything in by ID, just number. And the mapping of that is just going to go back to our like here, these numbers here. They just map directly, which is sweet. So we have like an input path, and here I guess we say if he starts with by ID, path. So there's ways to like interact with these path guys in Rust path. And we can just see how, like, is there a way for us to like take the first section of the path or something? Extension, file name, exists, ends with, starts with? Starts with. Determines or not whether base is a prefix of self. Right, so if we start with etc password, multiple extra slashes are okay. Yeah, okay. So we can say, do we start... Aha! And the starts with doesn't work unless it's like a full directory. So saying starts with E for etc is a no-go. And... okay, cool. So we can say if the path starts with by ID, we then take the second part of the path, and we just replace this by ID with like the source path here, and then everything else should just work out for free, I think. So can we just like replace the root of this in some way? Strip prefix returns a path that when joined with base yields self. Aha, so if I have test, haha foo, and I strip test, then I get haha foo, and I can append that to somewhere else. Nice. So actually, then I can have a strip prefix error if the prefix is not found, and so I don't actually have to do this test. I can just try to do what I want. Which maybe is reasonable. Path strip prefix by ID. Okay. And then we just join that with self db path. Is that right? He does have a path, but we need to expose him in some way. So we'll just pub function fs root or something. I don't know. Doesn't really matter. And this will return a path, and he will return self dot path like this. which then here we can say if let OK value is equal to this, then we just return the db file system root joined with the stripped thing. So this should go from by ID 1 should go to some path to db1. Okay, and then what happens in the other cases? What happens in the other cases? I guess, what is this function supposed to be doing? We're going to call this on every time somebody calls any function on us. And I guess we want to know what like the purpose of this path is. So putting this in like an enum that's like fuse client path. And then we can say like db path, which has a path buff. And then we can start like putting like other purposes in here, right? So somebody like the other thing that they might do is we might have like another section by name. And now all of a sudden we need to like switch behavior on this. And like we aren't going to be mapping those directly to these database paths now anymore. We're going to be linking, creating symlinks or something. I don't know. We'll figure it out. But I'm pretty sure that like we do need some sort of like flag to the caller of like what this path is intended for. And so us saying that this maps directly to somewhere in the DB makes sense. To me, for now at least. So here we say we're going to return a fuse client path, DB path, this thing. And otherwise we say we are unimplemented, which seems reasonable to me. Sure. And maybe map path is maybe wrong. Maybe we should call it like parse path or something, because we're like taking in the input and like figuring out what we think it means for us. Sure. And then depending, so get after will have to depend, our existing like functions that we have to depend on the path now. So these come in as like C strings, so we're going to want to convert them into Rust strings so that we can use them. So we can say unsafe, nope, function, what? C to Rust string takes in a S as a const C car, returns a reference to a static str, I guess, is probably the most correct thing to do here. And I think that we just use C str. So we pull in this guy from a pointer. So here we pull in C str, and then we say C str from pointer S. Now we have a C str, and we need to turn that into like a normal Rust string so that we can use him in the rest of our program without having to worry about this shit. So we have toString lossy toStr. That's what I want. toStr, and we unwrap him for now because we're in prototype mode. And we don't want to worry about error handling yet, but eventually we're going to have to fix that. Which means we probably also want to pull out this like client from context stuff. So we'll say what? Unsafe function get client is going to return a mutable reference to a fuse client. And I guess from our perspective, this will also have static lifetime, even though it's not technically true. And that's just going to do this stuff. Boom. Client. Okay. Okay, so now we can like easily get our client. And we can then map the path. Let what? Parsed path is equal to client map parse path path. Except our path needs to be a Rust string. So C to Ruster path. There we go. He doesn't like that for some reason. What doesn't he like? He expects a path, not a fuck me. So we'll just call this C to Rust path. And this returns a static path. And that means that we need to parse the C string, turn it into a str, and then do like path new from, maybe we can do it from this. No, he doesn't like that. Does not like that. So I guess we need to do as, or to, what was it? To str, to, I wonder which one of these guys maps best. To str unwrap. Certainly that'll work. Cool, yeah. C to Rust path. Okay, there we go. So now we have a parse path, and we can like switch our behavior based off what we see here. So I guess we'll have one thing is just root. The root of our like fake file system. Sure. And do we like switch behavior at the root? Yeah. So if we're at the root, we're going to want to show our like by ID. For now, that's all we'll show. So match parsed path. If we have fuse client path root, we're going to do what we were doing before. No, we're going to fill the root directory with only one folder by ID for now. Yeah. So we say filler buff how do we like construct a cster easily? From bytes with null as pointer. Can I just like, I guess I need a C string is what I need. Yeah. So we say let by ID folder is equal to C string new by ID. This is the only thing that we're going to show in the root for now. So what does that mean? We call filler buff by ID folder. And it looks like everything else just kind of like works out for free here. Which means here we probably want to have like by ID as well. Probably. We'll see. So this is what we show in the root. And otherwise we just say unimplemented for now. And we check if this compiles. And we run it. And we try to ls the root. Which did actually eventually crash because we hit this not implemented at line 76. So that's here. I guess instead of just crashing, we'll say print line unhandled path. And what is our we'll then log it and return fuse client path unknown. Yeah, sure. Sure. That seems reasonable. And here we don't need to return anymore. And then we're going to run it again. And we have to unmount test mount. Why do you need your custom file system when you have NTFS, which is arguably perfect? Well, I mean, I'm not actually trying to make like a real file system, right? What I'm trying to make is like a way to easily like view relationships in a database as a file system, which just is like essentially like a complex way of maintaining symlinks. And I'm just doing it this way because I was worried about like multiple direction relationships getting out of sync with each other, right? It's easier for me to like construct something from a single source of truth on the fly than to like worry about my like symlink A to B and B to A. What happens if I delete A to B, but I keep B to A? Now the relationships are kind of fucked up. So I'm just kind of using this as like a quick view into the current state, I guess. Umount, test mount, sorry. There we go. And then I can run this thing again. And ls test mount. And we still crash, but we're crashing at line 49 now, which is here. And so here we just have to say anything else. We just do nothing. And maybe we print line unhandled path key. And I think that makes sense. This needs to be marked as debug. Like this. And then he doesn't like that he crashed what was mounted, so you have to umount him again. Test mount. Mount him. ls test mount. So now I don't like what I expected to see here was the by ID thing. Why the maze animation is just for cosmetic purposes. Okay, so on TikTok, children watch videos of people talking and they just throw like clips of this game Subway Surfer on the side, just like as like a second video with an incredibly short attention span. A 3-second video is already too much. We can't handle that. But a 3-second video played next to another 3-second video, all of a sudden we can pay attention. So the maze is kind of like inspired by that. It's kind of like, I can't, I'm coding, which is kind of fucking boring. I don't know why any of you guys are watching this. But if there are times where you're like, you need something to like draw your attention, there's a maze on the side to look at. And to be like, is he going to get the end? Why is he stuck in there? What's going on? There's just something to like, give you something to do when you're like, I don't want to watch you code. I only watch this live for the maze. That makes sense. And I appreciate the honesty. Is there actual data proving that it increases the attention? I'm curious. Not that I know of, but it seems like I have had lots of like, what's it called? Empirical evidence that it's true. People that I talk to when I'm like run my stream past people because I want to like not be shit, right? People do say that they're like, they do catch themselves staring at the maze. And when I watch my streams back, I do also catch myself sometimes staring at it. So at the very least, it's doing something. That was more of a joke, but it sounds interesting. Why do you need symlinks in a database? Yeah, okay, so if you missed the project intro, it's essentially just that I want to have multiple way relationships between tasks. I want my tasks to just be folders or something that I can like use on my file system that I can like grep with and shit. And the only reason that I want to link between them is because I want to like quickly visualize trees of tasks, right? I have this like sequence A, B, C, D, and I want to be like, okay, if I do A, what does it unlock? Maybe it unlocks like B and C. Maybe it doesn't. Maybe it unlocks nothing. Maybe I want to look at like only tasks that are like unblocked that I can work on right now. And so the file system is just like ways to query the database quickly in a way that makes sense when I'm like editing files, essentially. As an alternative to like, Trello, right? Trello, you'd have to like write this like web UI that shows the database and has like cards that you drag around. This is similar. Obsidian, is that just like a thing that already exists? Obsidian knowledge base. Oh, I think I've seen this. This is the one that's like, yeah, similar to this. Links, yeah, it's very similar. But we're in the business of re-implementing the wheel ourselves. We make some like really shitty square wheels that we can appreciate round ones. Okay, what am I trying to do? I'm trying to make sure that the root of the file system is handled correctly. So we can also say if path is equal to this is just the root. Else if this works, Can't compare path with string. That's annoying. So can we just say like path new? That seems to work. That seems to work. And now when I run this, hopefully when I ls test mount, I see the by ID folder, sick. And when I ls test mount by ID, I see nothing, because that is an unhandled path. So, oh, but he does map correctly actually, which is pretty sick. So he is saying that like, yeah, nice. Unhandled path, test TV, sick. And so now we should just be able to say that our readdir implementation, if we get use client path db path with a path p, is there just like a readdir call that we can call readdir? I guess okay, so there's two options here. One is to try to just use the direct libc functions that map to our things, and the other is try to write a Rust function that will adapt into what we want. So let's see, at the very least, the libc crate in Rust. Let's see if there's something in here that like maps cleanly to what we want here. Like, do the signatures match? So this is not the same. Also not the same. Not the same. Okay, so at least for this specific call, it's not a simple thing. Oh, but I also think I saw a pass-through example in the libfuse GitHub. So I'd at least be curious to see what they did here. I think I saw a pass-through. Here we go. And readdir. Yeah, they have to do something manual here. So I guess we'll just do something manual here as well. So presumably in Rust, there's probably like some function that lets us iterate a folder. Readdir, nice. And we probably pass in the path, p. And what does this guy give us? He gives us a result readdir. That's sick, okay. So we at least have to unwrap this, which will crash our program if it doesn't work, but we're living with that for now, and we can look at readdir. Oops, we want the readdir here. And what does this guy do? He iterates over items of results of dir entry. Okay. Yeah, so we can say for item in this, we should be able to just map this guy back. So we say what? Let items equal to item.unwrap, because he might be an IO error, and we're ignoring errors for now. Or we're not ignoring them, crashing on errors, you know? Then we say filler buff item.file name. Yeah. Name is equal to item.file name. But we have to turn this into a C string. So C string new from this guy, because he needs to be null terminated. Then we use the name here. And for now, we just, I think, just call like that. Easy. He doesn't like this because we need to write as pointer here. And cargo check. From OS string is not implemented for VEC-U8. Oh, God damn it. What is an OS string? Do these have easy ways to convert into C strings? To OS string. Ugh. Is there no like into encoded bytes? That's probably what we want. That's probably what we want. Into encoded bytes. There we go. There we go. Okay. So that should be enough, I think. So that when we ls test mount by ID. There we go. Okay, so now we're getting like our original thing mapped back. What's kind of fucked up here is that we're getting our database of like metadata in here as well, which we don't want. So I guess we can just restructure the way that our source is laid out, just to like make this easier. So we'll just make a directory items, and we'll just yoink everything, put it in items, and then we have to adjust our database to expect that. So just when he creates items, I guess we will store here, instead of the path to like the root of our database here, we'll just call it like item path. Then our item path is the root path, but with an extra items appended to him. And then I think everything else just will work for free. Because when we create the directories, they'll just be in the right spot. Our database is the only other thing in there, or like our metadata database is the only other thing in there. We've already been opened. So I'm pretty sure that all of this just works for free. Pretty sure. Cool. And then we can run him. And we can ls test db items ls test mount by ID. And I guess what happens though if somebody just like happens to create some random bullshit folder in there? I guess doing it this way doesn't really make sense. And instead we should actually query what items we expect to be in the DB and show them. That unfortunately does seem more reasonable. It does seem more reasonable. So wherever we were in our Fuse client, when we map these paths here, I guess we have to... Okay, here's what we're gonna do. So right now we're kind of saying like, if our thing starts with by ID, we just map that directly back to like the source of truth. But we actually want this to be, if we have by ID, so if path else if path equals path new by ID, we say that we are the by ID section of our database, or our file system, I should call it. If then, only then do we try to strip the prefix. So if we're in a subfolder of by ID, we just map it directly. Otherwise, we're going to have to like iterate the database and put folders ID by ID, which I think makes sense to me. Which means that here we need to handle the by ID thing manually. And here, we're going to iterate the database. So we have what? Client db iterate items for item in this. And then we need to see, what does this guy return? He returns a db item iterator who actually only has his path and name, and so we're just gonna have to add an ID field in here. Which means here we just write ID and everything else works fine. Sure. Which means we can go back to the Fuse mod. Here we have client db iterate items, and here we just say let name is equal to C string equals C string new. We have the item ID as a string on wrap. Then we just shove them in there. Okay. So I think that might actually be all we need to like show all of the files. Let's go run again. So ls test mount by ID. And if we look at the content of 1, we are seeing the files that we put in 1, 2, and 3 at the beginning, but now we're seeing them always as folders, which is wrong. So that's probably going to be a result of us no matter what, just hard coding everything in a directory. So here we're just going to do the same thing where we like get our client, we parse our path, and depending on what the path is, we're going to do something different. So I guess we expect for now, we're going to say everything in the world is a folder for the time being, which is what we were doing before. And we're just going to iterate here and say, well, but if we have a use client path db path, if this is mapping to somewhere directly, can we then just look at the like stats of that guy? So we should call libc stat, probably. What do they do in the pass-through example that we were looking at? I would assume that they call, they're called stat. They call lstat, which I don't know if that's different than normal stat. Man to stat. Lstat, stat, lstat, stat. What's the difference? Lstat is identical to stat, except that if path name is a symbolic link, then it returns information about the link itself, not the file. Okay, so we want lstat. Cool. So I think that this means that we should pull in like the libc crate. And here we should just be able to call libc lstat, I think. Let's see. Lstat. Yep, sick. Path, buff. Easy. Easy, easy, easy. Easy. But not easy because he doesn't like this. So what is wrong here? Cargo build. He expects const ccar mute s and sysstat and libc lstat have similar names but are actually distinct types. Oh, gross. But maybe I can just call sysstat here. Oh, okay. So it looks like bindgen generated. Can I jump here? So it looks like they actually did generate a bunch of like normal C functions, which is kind of fucked up. It like benefits us here, but it shouldn't. Like that's that's not expected. But that's okay. So for now, I guess we'll just unadd that libc crate. We don't need it. And we'll ignore the fact that that's like totally fucked architecturally, and we'll just roll with it. As you do. Okay. So we're getting IO errors now, which is kind of interesting. Yeah, that's pretty interesting. I'd like to maybe look at why that is. How can we look at this? Let's see. So I guess we're not returning, we should be using the directory path, not this. This needs to be cast back to a C string, which is kind of annoying. So we'll say let PC is equal to P C string new key unwrap. And then we use PC here. Yes. And then probably this guy will return an error code, and we should actually return that code directly here. Okay, so const i8 found C string, so we need PC as pointer. And from path buff is not implemented revec u8, so is there like into OS string into encoded bytes. There we go. Does calling unwrap meaning you're not on done doing air handling? Yeah, so eventually I'm planning on doing it, but I kind of, when I'm in like prototype mode, I prefer throwing unwraps everywhere. Note that I'm using unwrap and not expect. Because what I end up doing later is then I say, okay, I'm done prototyping. I know how the program is going to kind of look overall. And now what I can do is I can just add a linter rule to ban unwraps and then just go through all of the places where it yells at me and turn them into real errors. But I find that if I'm like moving code around a lot, then like the error handling stuff kind of gets in the way because I might move the types around, like where errors are generated and where they propagate can change very quickly. And so I try to avoid doing that until I know where code's going to end up, if that makes sense. Hey, look at that. So we added stuff in test1 to that folder earlier. I think in IT2, we added hello as a directory with nothing in it. So it looks like the reading of directories is working as expected, which is pretty cool. But probably if we try to open this file, stuff. Okay, we'll try. Maybe we try to write something there. Yeah, we do get some errors at that point. But that should be pretty easy to like figure out where he's going wrong. So let's just do that again, and we'll see. So he calls lookup, getattr. So I actually don't know if getattr. Oh, getattr is what we just finished implementing, so that should be correct. Then he does getattr again. So what's the problem? Oh, open. He calls open on him, and maybe that's what functioning. Oh, setattr. Function not implemented. Okay, so why do we need setattr? Is it setattr or setxattr? Setattr. Function not implemented. So this pass-through thing doesn't have a setattr anywhere, which is kind of surprising. I don't know where this is coming from if that's not a function that we're supposed to implement. Okay, so what do? First of all, let's see if they're using the same version we are. Fuse version 31. Okay, sick. I'm pretty sure that's what we're using. I would assume that like our open call is wrong. We haven't implemented this, which is like, why would it work? I wonder what else can we look at here? So open, create, read, write. So certainly this needs open and write. But then why isn't it telling me that it's trying to open or write? I guess maybe the default open version, the default thing for open is maybe just not behaving sanely. So maybe we'll try writing open, just stubbing them out, and then see what happens. So to write a fuse file system, you have to handle what operations on the file? Move, remove, unlink, etc. I actually don't know. I kind of just like made an assumption when I started this project that it would be easy. But we could find out that that's wrong. I assume that like we have like a list of things that we could implement. All of these guys. But I don't know like how many of these we actually have to implement. Right? Like for what we have right now of listing directories and not being able to do anything with them, that's like two functions. Read dir and getattr. But like who knows how far down this rabbit hole we'll have to get, you know? Okay, so let's try shoving an open on here. Fuse client open. Which means we are going to have to go here, yoink this function sig, and stick him over here. And we'll call this fuse client open. Delete some of these fucking colons. Add a sys on here. Delete some colons. And here, this is probably the path. This is the info. And we return 0 and print unimplemented open for we need to map the path, I guess. So we say let client is equal to get client. Let path, let mapped path is equal to client map client parse path. And this is a C to Rust path. Nice. Then we can write the mapped path here. And this should be debug, not display. And I think otherwise that should just work. Cool. And now we can try echoing in here. And we see unimplemented open for this guy. Then he tries get x attr, set attr, release. Okay. Okay. So surely we should just call libc or a sys open, right? Surely. So what's in this guy? Use file info, flags, right? So like, surely we just say we want to open path with info flags, was it? Yeah. With info flags. Okay. And we only do this in the case that we have a database mapped path. Use client path db path key. We do this. And I guess we're kind of like in this like kind of like fucked up state. Kind of in like a little of a fucked up state where we're returning paths here, but we really want like C strings. Well, that's okay. We can just make another function here that's like C to Rust path, and we could say Rust to C path takes in a path as a path, returns C string, I guess. And then we say C string new, and he takes the path and he says what? Into our to path buff, into OS string, into encoded bytes. Nice, 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 nice. Have you checked out Space Drive? Nope. Never heard of it. Open source cross-platform file manager, powered by virtual distributed file system. What is virtual distributed file system? Designed to work across a variety of storage layers with a uniform API to manipulate and access many devices. Interesting. Not restricted to single machine. Virtual index of all storage locations. I see. So it's like a Rust user space version of Fuse, I guess, right? They probably provide operations for things, and then you can only use those things with this like specific file manager. Or maybe there are other consumers of this specific VDFS. Interesting. Interesting. Okay, so here, Rust to cpath p as pointer. Okay. Return here, probably. And info is a raw pointer, so we actually want to do it like this. Okay. So I wonder if that will change behavior at all. Because now they won't have a file handle to like our shitty thing. They'll have a file handle to like the real world. Well, they didn't like that. So we called open here and we got bad error value 5. Okay, so what's supposed to happen here? What is supposed to happen here? Let's look at their pass-through example. What did they do for their open? They called open with the path and the flags. Ah, I see. So we can only return errors. I see. So do you have Erno in here? No. Fuck. That's annoying. That's a little annoying. But that's okay. That's okay. So we can say, for now, we'll just not propagate errors correctly. So we'll say, let ret is equal to this. if ret is equal to -1, we return -1 for now. We'll put a fix me on here that says proper error propagation. Propagation. Yeah. Nice. With Erno. And then, if this succeeded, we have to assign the results to the info thing passed in instead of returning it directly. So we say info.fileHandle is equal to ret. And what else? Parallel detect writes. I don't know why we would set that, so I'm just not going to do it. And we'll discover why later when it doesn't work real good. Return 0. So why is he angry? He says that doesn't match. Oh, because he expected a U64 found I32. That's fine. Try into unwrap. Should be fine. Try to run. Okay, let's try echo hello again. Okay. So the open call succeeds. If we run this again, we're getting new file handles for each thing, but then we still, for some reason, have to like implement the like set-atter stuff. I would have thought that if we opened the original file, that fuse operations for those files wouldn't end up happening, but I guess they do. Okay. So we do just have to figure out what the fuck this set-atter thing is doing. Man2 set-atter? Is that like a thing? Man3 set-atter? Man set-atter? Man get-atter? So these just like don't exist. Can we maybe look at fuse docs? And we're kind of here. We're looking for... I guess we kind of did this stuff at some point, and at some point we started working on this. Let's see. Files, file list. Fuse.h. Fuse.h. Come on, where are you at? Fuse. Am I high? I am. Here we go. And then I guess we're looking for the operations struct. Fuse ops. Here we go. And can we just look at like what's on here? So I guess set-atter. They have set-x-atter, which isn't really fucking telling me shit. Similar to stat, forget. So is there just like no... Am I high? Why is there just no set-atter call? Libfuse set-atter. Maybe that'll... Ah! So this is a low-level thing. And probably this gets propagated to something else if we're using the high-level interface. So in the attr argument, only members to set blah, blah, blah. This method will not be called to update these things, only called implicitly, blah, blah. If the set-atter was invoked from the truncate system call under blah, blah, blah. If the open method will contain the value set by open method, or will be undefined if the open method didn't set any value, otherwise, blah, blah, blah. Okay. So shouldn't it be okay that that's failing if I'm not using the low-level interface? What is the like error that's happening on my end? Function not implement. That's such like a useless fucking return. And I bet you it really is this. Right? This is the only thing that it's claiming doesn't work. Can we like okay, let's go to test mount by ID 1. And can we like touch test? What does that do? Oh, my prompt line is doing all sorts of dumb shit here. That's annoying. Oh, okay, wait. So here, when we try to touch a file in here, just create it, it says operation not permitted. because I'm getting -1 from getAttr. So maybe that's going to give us... Oh, that's not any clues, though, because that's for creating a new file, which... Oh, that should map here. We should be trying to get attributes of a thing in by ID. So can we say print line handling path this? And try again. Okay, I'm gonna get out of this because CD a little bit. Because my prompt line, every time I run it, tries to check if I'm like in a Git repo, and that's just adding, like flooding this with a bunch of extra logs. So let's touch test mount by ID 1 test. Aha! So we have handling path, operation not permitted. That's interesting. Ooh. Okay. So it says that I should be able to write to this folder because I am the user streamer. But he's return? I'm getting a -1 operation not permitted. So was there somewhere where I was returning -1 here? I was returning -1 on open. What happens if I just return like -3 here? Just to see if it's like related. No, it's still saying operation not permitted -1, so it's not that. I feel like I'm missing something obvious. Where is their pass-through example? Pass-through views. I wish that like the logs were a little bit clearer. So on their getAttr, they do just call lstat, which is what we're doing. Something here is not right. Because it's also weird that when I touch, it's actually not even calling open or anything. What happens if I like strace this? Like what system calls is he trying to do to create this thing? Can we look at the... Maybe we'll put a unique late name in here. And then we can look for ASDF. So he's calling open at and then write. And open at is returning operation not permitted. Okay. So it's just this. U time n set. So it's weird that the open call is actually failing. I thought that should be working. So maybe here, can we print out what the fuck is going on? Yeah, that seems reasonable. So print line handling open call for this. And let's just make sure that that's doing what we expect. So where's the like open call? Oh, we don't even get the open call here. Or maybe we're not mapping it correctly. I guess it's only just getAttr. Okay. Yeah, so there's no opening happening at all. So it's strictly just doing a getAttr and then fucking dying. What does lstat return? Because maybe that's not matching up. Man to lstat. Return. On success, you're returned. Otherwise, -1 is returned. Ah! Okay. Okay. We're getting closer. Handling path, testdb items 1, ASD. Ah! Wait. Maybe this path has to be absolute. Maybe. So let's try when we map the paths. Parse path. Maybe we've made a mistake here where we need to type resolve here? Canonicalize? Maybe like the directory that like it's running the fuse stuff from doesn't handle the like the relative paths nicely. Okay, so now we try touching. Aha! Okay, so we've at least crashed in a way that we didn't used to. 135. Because fuck. The fucking canonicalize didn't work. Probably because the file doesn't actually exist. We have to pick a directory that does actually exist. Unmount, test mount, umount, test mount, cargo run, touch. Okay, is that any better? So handling path for this, and if I look at that thing, that doesn't exist, but the parent does. And if I try to touch that thing directly, that works fine. So there's just something to do with the fuse piping that's just like getting fucked up. And I guess it would be clearer if we knew why it was not working. So we'll go back to the lstat call and we'll say let ret is equal to this, and then we'll say print line ret return ret, and this will give us a clue. This is probably returning -1. Probably. Oopsies. Other touch. Touch. Where are you at? Here we go. So he's saying, okay, that's a clue. So lstat is failing, which is pretty surprising. So it could be that this is wrong. Can we print what the fuck we're looking at here? Print line PC. And can we do like as bytes stir from UTF-8 unchecked this. This will give us a clue to at least which path we're trying to do. So converted C path. Touch. So we are trying to touch this guy. So what the fuck is the problem? Why? Why? I see nothing wrong here. Oh. The file doesn't exist. Probably it's setting Erno to does not exist, and we're just supposed to handle that properly. Fuck off. Ugh. Alright. So probably if we were then to check Erno here, so cargo add libc, then we can say if ret equals -1, print line Erno is this, which can come from libc Erno, I hope. So we can look at libc on docs.rs, look for Erno. Really? Is Erno not part of this? Rust Erno. How do I fucking... Oh, SEOS Erno maybe? Can I just look for this in like the Rust docs? Or no? Oh. Here we go. So what is this? stdio error stdio error last OS error. And we say print line no is this. Yes. Okay, so ls or touch. No such file or directory. Ha ha ha! Okay. So we're close. We just need to then return the code. So let is this. Dot code. Is there like, can I just get the error code of this guy? Raw OS error. Yeah. And so if ret equals -1, we say last OS error, raw OS error unwrap. So this should give us an integer that we can just return negative. And I think that should do it. Let's see. Touch. Okay, yeah, we got farther, I think. So here, we got... Here they called getAttr, and we returned no such file or directory, which means that he keeps going, and he calls create and make node, and those things don't work. Sick. Okay. So we've gotten... that makes a lot of sense. So we have to correctly identify what the failures are, so that the tools that are calling our calling the operating system functions know what to do. That makes sense. Okay. So then, if we want touch to work, probably we just have to implement some sort of like create. Is there like a create thing in here? Yeah. Here. And all they do is they call open. All right. Sure, blaze it. Blaze it. So let's implement create. Use client create. And then we just yoinkies this function signature, paste it up here. Then we call this fuse client create. This is the path, this is the mode, this is the file info. This comes from sys. Yo, how's it fusing? It's going all right. We got a little hung up, but I think we've kind of caught up to where we understand a little better again. We got kind of stuck on touch not working for a bit, but we unlocked an understanding just now that should make this easier. Okay, so depending on the path, we're going to do something different. So we map our paths and we say match. I guess we will only handle create in the case where we're trying to write something in the DB. Otherwise, we return something that indicates not allowed. So I guess we'll return -1 for anything else. And then in the case that we do have something that we're allowed to do, we just execute open with the flags. Yeah, sure. So we say, can we just call open? Fuse client open. Is this crazy to do it this way? Path info. What is this like mode thing? Are they using it? They are. Okay, sure. We'll do what they do. They call sys open with rust to cpath of p with the flags given by info and the mode. Okay. And here we have to check the return value of open, and he's probably going to be the same thing where he's going to return -1 on failure and set no. Yeah. So we say if ret equals -1, we do our no shit. So I guess we just say return. I guess we'll make a function here, no, which just returns an I32. And what is he going to do? He's going to call that like last error shit that we did in the other guy. This. Yeah. So here, I guess maybe we even just like make it a macro. Macro rules, return erno. Because that way we can just write return erno and not have to worry about like handling this like negative and shit. We can just do this. Boom. Boom, boom, boom. And then here we can just write turn erno. Like this. Okay, so what's new like here? Rust to C path returns a C string. So I have to write as pointer here. And this needs to be a borrow. Other than that, I think that's working. So can we touch this guy now? Operation not permitted. So where did we get to? We called lookup. We got no such file or directory. Then we tried to create, and then we got -1 on create, which is kind of interesting. So let's see which path we took here. So let's kind of just try to get rid of some of these useless prints that are flooding our logs. Oh, here we can fix this. We can say return erno right here, which will help us. Here's another print line that we don't want. And then here we want to see if our create call is failing. So we're going to say print line to see which path we're taking, the mapped path. Mapped path. And here we're going to say mapped path in create is this. And that will give us some clues. Oh. Okay, so I think something different happened this time because in open we're correctly propagating errors now. And so now he's trying to do open, flush, set adder, release. Let's look at what he's doing now if I try to write as well. So we can say echo test to this file. And this guy, he's getting function not implemented, probably on set adder again. And we never really figured out why set adder, like how we're supposed to implement set adder for our thing. But we can probably assume that write is going to be one of the things. Like, because there was like the low level interface that has set adder on it, and the high level interface doesn't have set adder. So then why is it saying function not implemented? We could also look at maybe the code in libfuse for the high level interface. That's probably what makes sense here. So can we maybe look for, who am I looking for here? We're looking for set adder, I guess. Or maybe we're looking for the high level interface here. So high level, because presumably there's like some like default functions that are being called somewhere, and we can look at what those are. So what are we calling? We're calling fuse main, which is going to have some code, fuse main real. What does he end up doing? He calls like a fuse loop, fuse session, fuse mount, fuse new 31 sounds probably like where the like bindings are gonna happen. So where's this guy defined? Fuse new 31. Struct star fuse new 31. Oh, that's surprising. Oh, I see. So this is a function. And I guess here he's going to use these operations somewhere. So he's going to create a fuse fs new with the ops. what's he doing with these ops. He's memcopying the ops somewhere. Is memcopy desk source or source desk? Man 2 memcopy. Man 3 memcopy? Desk source. So he's going into this. I see. So we can look for op somewhere. Somebody's gonna call op, like, who calls like op right? Aha, okay. So someone calls fuse fs right buff on fuse fs right. Fuse fs right. Somebody must call this guy somewhere. iconv right. No, actually, weird. So where is this used? Hello? Fuse fs right. Maybe this just isn't used anywhere. Fuse fs set adder. Oh, okay. No. Ops dot op dot set adder. Like, how are we getting into this path? So somebody calls do set adder. Aha! Okay. So somebody's mapping fuse set adder. They're jumping into this table of calls. Okay, that makes sense. But again, this is only on the low-level API. So does the high-level API like map to the low-level API in some way? That would make sense to me. So can I look at like somewhere in here? Where is like the high-level setup? You know, fuse loop. Fuse session process buff. That sounds right. Fuse session process buff. What's this guy do? So he does some like low level shit. LL standing for low level. Where does the high level stuff get called? Like, where's my op.open, for example, being called from? I feel like we're missing some like very important piece here. Fuse fs open. So fuse lib open goes to fuse fs open. And where is this guy called from? Fuse lib open. Aha! Okay. So by default, they have all of these functions. Ah! So they create low-level ops. Yeah, okay. So I give them my high-level operations, and then they map those to low-level operations. Which means that here, we should be able to see when they're calling setAdder, what would they do? So they check what it is. So it might be a chmod, it might be a chown, it might be a truncate. And if any of these fucking fail, then we're getting this. Oh, okay, so there's like a bunch of things that we have to implement here for this to work at all. So I guess we just look at chmod, chown, truncate, and we just see which one of these we're hitting. Is this how I'm supposed to find this out? Like, this feels like, I feel like this happens to me a lot, where I'm like, I'm gonna browse code to find the answer, and I feel like my ability to extract information out of docs is very, very poor. But when I was looking at their docs, I didn't see anything about, I don't know how, but I guess I'm just how did I even get here? I just went in here and I typed -d and started looking at what came out. And I don't know. I didn't read any docs on how am I supposed to make a fuse file system. So maybe this is on me. It's probably on me because I haven't done any reading. Okay, fuck it. So let's see which calls at the high level are getting called from the low level op. Do they not log this in any way? Fuse fsch chown. Fuse log chown. Oh, okay. So maybe there is some information here. So in in the like set adder somewhere. ls this. Okay, we wanted to touch ASDF2. Cannot touch. No such file or directory. Oh, because I'm in the wrong directory. Oops. Touch. Okay, so here they're calling set atter, and then it just says function not implemented. But does this like unique 12, unique 14, if I call it again, unique 30, unique 38, unique... So that doesn't really help me. But I am not seeing chone in there. I wonder if fuse log debug. I wonder if I'm getting debug logging. Can we look for like unique, or like where are these other things coming from? Like open flags. Okay, so this is, we are getting debug logs, which kind of at least indicates that we're not. Ooh, wait, hold on. Enosys. Is that the same as not implemented? Oh, fuck, maybe. Man, so this is function not implemented, negative 38. What's enosys? Enosys. Fuck off. Or no. Does this show... I hate how this doesn't tell me the numbers. I just want to know the fucking number, man. Here we go. Chromium OS docs. Enosys. Negative 38. Aha! So, unfortunately, these debug logs are, like, almost fucking useless, right? Because we just know that, like, if they try to call, we get, like, a set adder. We don't know what it's asking, right? But we do know they're calling set adder. And maybe they're calling chmod. So we go to the chmod thing and says, well, if you've defined chmod, then we'll run it. Otherwise, who fucking knows? We'll say not implemented. And so we just have like not implemented coming out for like fucking anything. Oh, is there any way to like extract that info a little bit better? Oh, that's fucked. So I guess we do just have to implement all of these things. Okay, well, let's see. What's the if letter say? They say, we try to get the path. And if we got the path, okay, then we might try this. And we'll set err. Yeah, so it's just like if any of these things fail, it might fuck up. So we actually probably just do have to fucking stuff them all out. That's so fucked. But it is what it is. Okay, so we have chmod, chown, truncate. Ops chmod is equal to sum fuse client chmod chown chmod chown and truncate. It would be fun later to think back on this and be like, was this easier than implementing a web UI? Because I actually at this point am starting to feel like, as always when I go, that's gonna be easy, you know, maybe I'm wrong sometimes. And maybe things are actually more complex than they seem sometimes, shockingly. Okay. So here, this is fuse client chmod. This is fuse client chown. So this is fuse client chown. Then again, what we also have to think about is this fun, and is this a skill that I'll need in the future? Certainly the answer to is it a skill I'll need in the future is no. Nobody will ever need this. But is it fun? Yes. Yes, it's fun. Okay, so we'll just return 0 on all these for now, and see if that unlocks this for us. Fuck! Did I spell truncate wrong somewhere? Fuse client truncate. And here I said truncate. I have to fucking fix all these prefixes. So this is sys sys, boom. And now we can try touching again. Wow. Still not implemented. So let's see if we at least called these things, because then at least they'll give us some clues if we were on the right path or not. This is chon, truncate, chmod. And we can touch. Wow, so we actually didn't do that. Which kind of indicates that I don't know what the fuck is going on. Interesting. Oh, so maybe we are not in fuse set attr mode. What is valid here? Int valid. Okay. Can we... Interesting. So maybe it's just a random... Maybe like it just happens to be that they're calling with a specific flag. So I guess we're just having to... The only other one that we haven't done is utime ns, I think. So we might as well just try that one and see if that solves it. Hello, I recognize you from YouTube. Hello, welcome. Welcome, welcome, welcome. So utime ns is the one they want to set here, I think. Yeah, so we'll just try implementing that. Which then we need to go to here and we need to pull this guy out. I saw your video about hooking up USB control to the OS. Very interesting stuff. Thanks. I appreciate it. Appreciate it. I'm hoping to get to the OS stuff again at some point, but other things have become slightly more interesting to me in the immediate future, and I kind of feel like it's better to like do more variety and keep my own interest up versus finishing anything. But maybe over time I'll find out that that's not the way I should be behaving, but for now, it feels good. Hey! Okay! So it just fucking happened. Okay. So I think that we do understand to some extent. So this set attr call is being piped through to this low-level thing implemented in libfuse with the like, I guess with the like argument that they're saying like we're gonna make this easier for you. But it feels like it made it so much harder because there was no logging indicating to me what the fuck wasn't happening. It just says function not implemented. And it just happens that the last thing we tried was the one it cared about. So touch was trying to set the time on something. That wasn't working. Boom. Everything fucks up. Okay. Sure. But that's pretty cool. We should now see that on our test mount, we should see that we did create some files, which is pretty sick. Pretty sick. And so now if I touch thing ASDF3, that should show up, ASDF3. And can I write into it? That's probably like the last thing here. So echo hello into that thing. That won't work anymore. But now we're seeing a very clear flush and write failure. Okay, cool. So we should actually probably like properly implement these functions that we stubbed in before. But maybe before we do that, I do want to see a write work. So we will have to come back to those. But for now we will ignore the problem as always. And maybe we should print line in these unimplemented on all of these so that we don't lose track of them. Chon, and chmod, they don't really matter. Truncate, almost certainly we actually do have to implement. Set time probably also doesn't fucking matter. But truncate, I can imagine if we don't implement that correctly, causing problems down the line. Okay, so what is the pass-through example say for write? It's probably pretty fucking straightforward. You take path, buff, size, offset. Path, buff, size, offset, info. And they check if they have a file handle already, and if they do, then they can just call write on it. Sure. So info.filehandle. Hello? Info.filehandle? Why is that not? Oh, because it has to say sys in front of it for the type system to resolve correctly. Okay. So if info filehandle equals null. All right. We'll say if this equals 0, we need to open. So fuse client open path, and with sys o write only. Okay. That seems reasonable. Then we should have a file handle. If he's invalid, fix me error handle on invalid file handle. Otherwise, we just call write. So we should just be able to call sys write. Really? Oh, man to write. So how come like half the shit from the standard library is pulled in here, but like the other half isn't? Okay, whatever. libc write. I should have libc in here. I thought I had libc as a dependency. Oh, I don't. Cargo add libc. Okay. Let's try again. So we go here and we say when we somewhere we try to write libc write, and now we can write with info.filehandle. And what else does he expect? File handle buff size. So we should just be able to write here buff and size. Fix me handle offset for sure as well. And our file handle should be try into unwrap. I don't understand why this is a U64 instead of a int. But whatever. We'll see how this gets fucked up. This definitely shouldn't be const. This should definitely be mutable, right? Because we're writing to it. And libc write expects this to be buff as mute c void. But other than that, that's probably fine. Here, I guess we want sys open path o w only, so info.fs equals this try into unwrap. Okay. And this should be like this. I think all of this works fine. Fix me handle write error. I just want to see that in the happy path, this does what I expect. Types different in mutability. God fucking damn it. Okay, so we just say that this is const, and then we fucking lie, I guess. Okay, touch. We knew that worked, so we were trying to echo something into it. Echo hello into this. Input, output, error. Fuck. Alright. So we have, let's look at if anything actually got written to them and it's just flagging incorrectly. Okay, so the file did get written. It's just our error handling is not working right. And kind of like the more I get into this, the more I'm starting to feel like this way of doing things is starting to become a pain in the ass. So someone in my YouTube comments yesterday pointed out that there is a Rust library fuser that's like a re-implementation of libfuse in Rust that uses Rust types to make things a little bit more reasonable. And I think that the more I'm working with this, the more I feel like I'm not really dealing with the actual problems I'm trying to solve, but I feel like I'm dealing more with like C Rust interop, like stuff like Erno handling, stuff like mapping car pointers to Rust paths and stuff. And so I think we kind of got to the point where I'm writing a file in here, and I think that I do want to just see if a lot of this becomes easier if I switch to using the like a Rust library that's handled this. So what this is like yesterday when we were like looking, we were like libfuse, and we looked up libfuse on Cargo, and we were like, nothing in here looks like what people are using. I just didn't notice this like fuser thing down here, but I felt like there weren't like proper fuse bindings that hadn't been updated in like the past 6 years. But it looks like this fuser thing is like actually used and maintained. So I think probably what I'm going to do is I'm going to call it here for today. Say we did accomplish something. We did manage to get to the point where like mapping folders from our like source where like the data actually lives into our like fuse file system. We can like write stuff in there even if our errors aren't being handled quite right. And yeah, so we've got like something, and I think that what's going to happen is I'm going to come back tomorrow and try switching over to Fuser and seeing if that works better for what I'm trying to do, which I imagine it will. Yeah. All right. So thanks for watching. If you like what you saw, I stream most days at around like 1 or 2 o'clock Pacific time for around 1 or 2 hours. There is a YouTube link in the Twitch description if you want to, watch VODs that you can like watch at accelerated speed, jump around in, whatever. If you're watching on YouTube and you want to come swing by on Twitch and say hi, shoot the shit. There's a Twitch link in the YouTube description. In the Twitch description, there's also links to GitHub and Discord. So in Discord, I kind of post like a little bit of a heads up about when I'm going to be live in a day, as well as like we can chat about programming and stuff, whatever, when I'm not streaming. And this project will eventually end up on GitHub, but it needs to be in a state like I don't like to commit like the initial prototype. I like to commit kind of the first thing that I consider reasonable, like that I would want to look back at in the future and be like, that is code that is worth being committed. So probably what's going to happen is we're going to get to a point where we have like a very minimal, what did they call it? MVP, something, minimum viable product. And we'll probably commit that, and that'll end up on GitHub at some point, but not today. Yeah, that's it. Thanks for watching, guys. Catch you on the next one. Bye.